Hello class and Professor Timmy's. I'm Aethan Mackey, and today I will be explaining how both an acoustic and electric guitar convert energy as well as how they work. Okay, so to start off, there is potential energy and both the strings of the guitar and in my hand that will pick the guitar. And whenever I pick a string or strings of the guitar, that potential and kinetic energy then converts into sound energy and thermal energy in the air around me. Okay, so as we all know, all sounds are produced through vibrations. And on a guitar, whenever I pluck a string, the vibrations of the string transfer from where I plucked it to the saddle and the bridge of the guitar, and then through the, right here, the soundboard of the guitar, through the hollow body of the guitar, and then out this hole, and then into our ears. As you might have noticed, each string gives off a different pitch that you hear. So these strings are actually thicker than these strings, and the thicker strings sound lower than the thinner strings. And that's because the wavelengths are actually going slower than the thinner strings. And there's a few ways to change how, the speed of the wavelengths, therefore changing the pitch of it. For one is changing the thickness of the string. Another one is as you cut off the vibrations by, let me try to show you, these metal frets right here, as you cut off the vibrations, making it a shorter vibration, it then speeds up the wavelengths. So as you can tell, it's getting higher in pitch. Another way is by just tuning it to make it tighter and therefore making it sound higher. Now that we are done with the acoustic guitar, this is Blackbird by the Beatles. So the electric guitar is different in that it converts the vibrations into an electric current instead of sound energy, and that electric current is then sent into an amplifier, and an amplifier is basically like a speaker. Now the pickups actually do most of this work of converting the vibrations into an electric current. And if you could see, these are the pickups right here. There's 3 different ones on this particular guitar, and there are 6 different components to each one for each of the strings. And what a pickup is, if I was to take it out of the guitar, it's 6 different magnets that's wrapped around in a very, very thin coil, like it's copper, like a copper coil, and it's very thin. And then basically the metal properties of the strings interact with the magnetic properties of the magnets. All right, so this is the pickup selector, and I've selected this pickup for now. And this is the pickup has a magnetic field that is surrounding it, and this magnetic field is disturbed whenever the string vibrates. And then the current, the electric current from the that's picked up from the magnet actually fluctuates with the vibrations of the string, which is why it's not. Lastly, this tuner, this pickup selector right here, selects which pickup you want to use. And as you can hear from the frequencies coming out of my amp, it's fluctuating. There's higher frequencies because in the strings right here. So if I were to select this pickup, it picks up higher frequencies better. Or if I were to select, this pickup, it picks up bass better. And this one's just like in between. So if I were to pick like a bass note and then switch it to, it sounds more flat. Or if I were to, which is higher. Now that I've explained how an electric guitar works, I'm going to play the solo of Santeria by Sublime. Thank you for watching my explanation of how energy is converted in both an acoustic guitar and an electric guitar.